So in this next opener, 11, we're trying to find the pattern between how H relates to B and C. Because if we can see that pattern, then we're going to save a lot of time and spend a lot of our brain power on things other than squaring a binomial, which is what this is. Now the first thing I want to address is that this is not the same as x squared plus 1 squared. Right? You cannot distribute an exponent over addition, only over multiplication. Now if the problem was 4x squared or something like that, then yes, that is 16x squared. But again, this is multiplication that I'm distributing over, not addition or subtraction. So this is not true. The way you could prove it to yourself is plugging in a number like 4. Is 4 squared plus 1 squared the same as 5 squared? You'll find that it is not, that 17 is not the same as 25. So that is not the pattern. Right? This is not the same as the difference of squares. This is a quantity of a binomial squared. So squaring a binomial, squaring it is the same as multiplying it by itself. So let's do that. X squared plus x plus 1, which is the same as x squared plus 2x plus 1. So as we go through, I just want us to notice that number as it compares to the 2 and also to the 1, and see if we can find any patterns. Looking at the next one, x plus 2 times x plus 2 is the same as x squared plus 2x plus 2x plus 4, x squared plus 4x plus 4. Again, let's note the numbers. How does 2 compared to 4 and also 4? Not seeing any patterns yet, but let's continue and see if we can maybe see some more. Alright, so here we have x plus 5, just x plus 5 times x plus 5, x squared plus 5, x plus 5, x plus 25, which is just x squared plus 10x plus 25. 5, how does it relate to 10 and 25? Well, for some of you, 5 is a number that makes some patterns easier to see. And I'm starting to see one. Let me list the numbers in a column and see if that might help you. So what I see here is my first number is 1, and then a 2 and a 1. And I'm trying to figure out how does this 1 relate to these other 2. The next one is 2, 4, 4. The third one is 5, 10, 25. Now with 5, 10, 25, I know, doubling 5 is 10, and multiplying 5 by itself is 25. So let's see if that holds up. So if I call this row x, I call this 2x, and this one x squared, and let's see if that holds up. So it's 2 times 2, 4. Is 2 squared also 4? Yes. Is 1 times 2, 2? Yes. Is 1 squared 1? Yes. Let's look at one more. Maybe I'll make up one. X plus 7 squared is x squared plus 7x plus 7x plus 49, which is x squared plus 14x plus 49. Does that hold? 7, 14, 49. 2 times 7 is 14. 7 squared is 49. Check. These all work, and that is your pattern. Let's go back and see why we believe that's true. So if I squared x plus h times x plus h, I would get x squared plus x, let me write it as plus hx plus hx plus h squared. Simplifying that, that's x squared plus 2hx plus h squared. And so you'll notice that the b value is in exactly the same spot as the 2h, and the c value is in exactly the same place as the h squared. So in fact, that is the relationship. That if you take the number, for example, the -1, you double it, so that'd be -2. That becomes your b value. And if you square it, that becomes your c value. Now let's just confirm, just to be sure. X squared minus x plus 1, which is just the same as that. So now this pattern, if we can recognize it in squaring a binomial, will help us speed through these things. So x squared plus double the h minus 4x plus h squared plus 4. Here again, x squared double the h minus 10x plus 25h squared. So how does h relate to it? Well, 2h is the same as b, and h squared turns out to be c. So if you can see these patterns and you can start to learn them, all these procedural things that might take you some brain power and some time will become easy, and you can start to spend your brain power on what do you do next, not what are you doing now. Hope that helped.